Amplifiers, integrators and filters. And this first film is about the basic amplifier theory. So what are amplifiers? Amplifiers are circuits that amplifies a signal. That means that it makes it stronger. And so you have a weak signal like that one here, and you want it to become a strong signal for example, a speaker. And in order to get that, you need power from somewhere. So you need power to drive the amplification. In the figure here, which I by the way stole from How Stuff Works and modified, I added the power supply because that's necessary. But in this figure it says here that the circuit carrying a large current and circuit carrying a small current. Well, I would really modify that to say large power, and here small power. Because amplifiers can amplify voltage, they can amplify current, and if they amplify both, you know that the power equals the voltage multiplied by the current, so also the power is amplified. So they are basically power amplifiers. The amplifiers, they have something called a gain, and that is how much they amplify. So the output, if you have voltage, the output voltage, it's some kind of gain multiplied by the input voltage. So the amplifiers are specified by the amount of gain. A for amplification, or sometimes G for gain. So you will find both. So the gain or amplification is the proportion V out over V in. And in many cases we build our own amplifiers by using discrete components like transistors and resistors, but we also have so-called integrated circuits that are pre-made amplifiers. And here is an example of such a pre-made circuit. What you see here is a so-called operational amplifier. Often called op-amp for short. And they come in these versions and also come in these versions, and they have all the necessary components embedded inside them. You see, I've written the dimensions here. They are the size of a fingernail, or half a fingernail maybe. Here is what you will find inside such an operational amplifier. What you see here is a great number of transistors. I haven't counted them, but let's say that you have 20 transistors and a number of resistors. And together they make the amplifier, which has a symbol like this. So fortunately you don't need to draw all this every time. In a circuit diagram you simply draw what you see here in the square box. You have 5 connectors. You have Vs plus and Vs minus, and that is the power supply. As I mentioned in the slide here, you need a power to drive the amplification. So you need power supply. What you see is a positive and a negative power supply. Well, if you have a sine wave like this, and you want to amplify it, means make it stronger like this. In order to pull the sine wave upwards, like here, you want to pull it up, you need the positive supply. And in order to pull it down, like here, you need the negative supply. So you need both in order to pull it both upwards and downwards. Also, of course, you will have the output signal, which is the output from the amplifier, and then you have the input signals. plus and minus. Well, you have two, which means that it's a differential amplifier. It amplifies the difference between the two input terminals. Now, you always connect some components to the amplifier to build the amplifier for your specifications. So if you, for example, so this has a very, very large gain. An extremely large, almost infinite. So it's basically like 200,000 or something. What you do is that you connect the components to it, which will reduce the amplification from infinity, or infinity more or less, to the value that you want. So if you want an amplification of 10, which means that the signal out is 10 times stronger than the signal you sent in, well, then you adjust that by adding extra components, which we will look at in the next film. Also, for this amplifier, they are made in such a way that if you see here, they are made because of these transistors and how they are set up. They are built in such a way that the current that goes into here and the current that goes into there is basically zero. What that means is that we can amplify without disturbing the circuit that we are measuring from. So if I do like this, if I have, for example, one circuit here, and I have one circuit here, and I want to measure a signal here, I want to connect that to my amplifier, and I want to use that somewhere here in circuit 2. Well, that didn't look too good. So I want to use it here in circuit 2. What I do now is that since there is no current flowing into the terminals here, I do not actually disturb circuit 1. Circuit 1 goes unaffected by the fact that we take something from it and use it here in circuit number 2. But what we take here is the voltage. So we use the voltage over here on the other side. But we do not take currents, so hence we do not take power either. So to sum it all up, amplifiers, they need power. They have gain, and that is the proportion V out over V in. So how much do they give out compared to what they took in? You also have so-called op-amps, which are pre-made amplifiers. The only thing we have to do is to connect a few components to the pre-made op-amp to build a full amplifier, and that is what we will go through in the next film.